Olá, sejam todos muito bem-vindos e bem-vindas a mais um Fraunhofer Quick Lives, dessa vez falando mais uma vez diretamente da Alemanha. Eu sou o Rodrigo, sou head do Fraunhofer ISC Brasil e junto comigo está o Dr. Victor Trapp. Eu vou agora passar para o inglês e vamos ter uma conversa agora com o Victor, que vai nos apresentar um pouco mais sobre a parte de packaging, né, sustentável. Hello, Victor, how are you? Thank you very much for being here.
Oh, hi, bom dia.
So we are really excited and having you here from Fraunhofer ISC. That's in Würzburg, right? And man, the stage is yours. You can share, you can present yourself, and go.
Okay, great. So then I share my screen. I hope you can see the presentation now.
It should appear here on the platform. Not yet.
Okay.
You just click on sharing. You need to select the screen that you want to.
Okay. I just try to do it again. So maybe.
Yeah, now I can see it right now.
Okay.
Perfect.
Okay.
Yeah.
Very good. Very good. So then I just switch into presentation mode.
Great. If you had any questions, you can just ask and I appear on the live.
Okay. Okay. Perfect. Then bom dia to everybody in Brazil. So very nice to all of you listening here, and I hope to give you some good ideas, some solutions for some future packaging.
Victor, just one.
Yes.
Sorry to interrupt you. We can see only your slides, not the presentation mode.
Okay. Can you? You don't see the presentation, so
no.
Okay. Okay, so I don't know.
But you can try to put on the presentation mode, and then when you share the screen, you can take the screen off, and then when you share the screen, you can only select the presentation.
Yeah.
Maybe it could be.
Okay. I try again.
Don't worry, take your time.
Okay. So I go to share, and if that doesn't work, then I just try to have a PDF version of this.
We can see the slides, but try to put on the presentation mode. Is there already?
Okay, I try again.
No.
Yeah,
you can see. Yeah.
Can you see now?
Nope. Are you sharing the screen or the PowerPoint?
I'm sharing the screen actually.
Wow, weird.
Okay. Okay, I have an idea. So let's find a technical solution. I will just try to save it as a PDF. Let's do it this way.
Can be.
And then if this should work, I hope so. Okay, now I just tried again. Just hold on, nicht mehr teilen. Let's I go back to this platform. I go to share. Now it's the PDF. Which
perfect.
Okay. So here we go. Perfect. So now you tested my ability to solve problems. Okay. Good.
You were accepted. You approved.
Okay. So yeah, sorry about that. So I just go ahead. So So basically, in my presentation, I will just show initially the problem. Let's say it's more like a problem statement, and then I show you a lot of different nice solutions. Again, if you have questions, then just keep asking at the end of the session. So in principle, a lot of food is packed in plastic composites. What does that mean? So as you can see here, that's a typical packaging you find all over the world for food. And many people think, this is just like some plastic, some polymer. So what is the problem? The problem is actually very easy. And at the same time complicated, because this is not just a polymer, it's actually a composite film. Sometimes it looks like this. It can be even more complex than that. A lot of different type of polymers, different type of other materials, and very much densified in a very thin film. So it is a composite film for many functions. And the problem is that this type of film is not recyclable. And of course, it's not compostable. So what's happening with this is it is either incinerated or put into landfill, or it ends up in nature, poisoning nature, animals, of course, also us at the end of the day. So that's a big problem, which has been recognized. And here you can see, of course, some not so nice pictures of what's happening with too much plastics packaging. However, the problem begins long before the plastic reaches our oceans, rivers, and beaches and fields, but also the solution to the problem. So this is basically just a starting point to let you know what is the problem, and now we come to the solution. So the motivation for our work was to enable sustainable and environmentally friendly packaging. So we wanted to generate some solutions for packaging which are compostable as well as recyclable. So again, we want to increase the recycling and composting rate worldwide. So it's not just for the European packaging, but it's for many different countries with different type of packaging, different type of recycling systems, etc. Very useful for all of it. So we have developed a so-called multifunctional barrier coating. Actually, we've been using a toolbox, a coating toolbox, which we have been developing for many years already. So we have developed a polymer type. I explain a bit later what that is, which we call almost there, and the new development is a bio almost there. So this is actually something which we've developing for 30 years already for different applications. So this type of coating can be used on many different type of substrates, on polymers, glass, metal, and I put here on anything, and it's really true. So you can put it on even on natural products, on textile. Yeah, so no exception really. So that's one of the good news about this material. Then it can be easily processed. You can basically dip coat, spray. You have many other options also for UV or thermal curing. So here you see some pictures, some impressions of that, and we have a lot of these different technologies around. And then so basically we develop this and we also upscale it. So then we have we have also the capabilities to have the processing, etc. We can provide it with different surface functions. So we have here, for example, hydrophobic, hydrophilic. Again, many different surface functions are possible. And then of course we also provide the testing characterization. So basically in this very thin film, a lot of different options, different substrates, different processing, different functions, different final properties. So how does it look like? This is basically the way how we have, let's say, simplified it. Even if you are not a chemist, it's easy to understand. Basically, we're taking the combination of a glass-like material and a polymer-like material, and we combine it in one single molecule. We call it a hybrid material. So it's not just a physical mix, but it's a chemical design. So in this case, we are combining two worlds, the ceramics and glass, with organic and polymers. So here we have the typical properties like hardness, temperature resistance, high barrier, very important, and chemically inert. At the same time, from the organic or from the plastic, it's lightweight, low temperature resistance, and flexibility, and many other options here for different type of functionalities. And it's easy to process. That's very important. Then we have taken it even further. So we have been introducing a modified biomaterial. So in principle, the biomaterial now is part of this big molecule. And I show you what that means. So what is it good for? So again, two type of materials. One is the let's say the original material, and the other one is, let's say, the new kid on the block, right? Let's say. So here we have been basically we've been combining the silicate with bioorganic structures. So basically, and we've been even using bio waste. So you can even use bio waste to do this. And here is the silicate type material, which we basically use to build this type of molecule here. So we can make this very thin coating. And then with this coating, you can make packagings. And so there are different advantages. And again, this is just like a little bit like looking what the nature does. So in nature, there are different type of plants and animals, which also have the combination of silicate and bioorganic structures. And for that development, we received about 3 years ago at the Davos World Economic Forum the Innovation Prize from the Ellen MacArthur Foundation. So in this type of coating on a biodegradable material, for example, on PLA or on paper, for example, is biodegradable, right? So basically, we've been playing with different versions here, but you can see here after 6 weeks of composting, it is basically already very much biodegraded. So it is definitely biodegradable under composting conditions, and we can even adjust it to home composting, right? So again, we've been testing that, and we have some certificate for that. So it is already, let's say, industrially proven. So so what is the magic about this type of material? So one of the very important properties is the barrier, right? Again, very important, oxygen and water. So everybody in packaging is looking for that. So in order to preserve the food and or the medicals and other stuff, so the barrier against oxygen and water vapor is very, very important. So for let's say a standard polymer like BOPP, this value is very, very high. So I just remarked that we have just cut it because the scale would be too big, basically. If you put almost there on it, then you have already a factor of about more than 100, basically, in improvement. There's something which is being used for some packaging already today. It's using SRX as a coating, so it's even not as good as almost there. But if you combine SRX and almost there, then you're really, really low in the barrier, right? So this is really what the food packaging and the medical packaging industry is really looking for. So basically, the combination is even much better than the individual coatings. So in case of just another example, this is a PLA. This is a biodegradable polymer. So here, this is the water vapor, for example. Very high value. With SRX, you can already reduce that, and if you combine it, then it's even much better than that. So it's just another idea to understand, okay, what does it mean? So for example, typical packaging is PET and SRX, which is already quite good. So it's in this case, it's already quite good values. But if you then combine that with bio almost there, or with a standard almost there, then the values are even much lower, right? So again, there are different improvements and options here. Now, a lot of companies all over the world are now looking also for packaging based on paper instead of polymer. So very, very interesting topic. It's not so easy. However, even there, we have achieved a lot of progress. So here's a microscope picture of a paper. And you see the paper is very porous. So because of the porosity, we use something which is standard in industry as a pre-coat. So it's a cheap material which is being used for some different paper applications anyway. So we use in this case a pre-coat, and then the almost there is put directly on it. So even here you can see that the surface is very uneven, but that doesn't matter because almost there is basically leveraging that. So it is making the surface very, very even though the original surface is very, very rough. In some cases, we can even use also compacted paper. So in some way, you can pre-treat the paper with some hot ironing, something like that. So then you don't need a pre-coat. So again, this is something which is also industrially, let's say, very easy to be accomplished. So the only condition is that the paper should not absorb the lacquers either by compacting or by pre-coating. But again, here we have some industrial solutions available. So you can see some example from a very, very different application. So we've been looking at paper-based electronics, but the story is the same basically. So here the surface. So here's the roughness. Here's a scale for the roughness of the paper surface. So it's very, very rough. So it was not possible to coat SRX, for example. then we coated this paper first with almost there, and then with SRX. So you can see here, it's really, it's very, very smooth. So you can have some few nanometers of, let's say, roughness. So again, very impressive how that works. And then, and this is something which is then, as a result, is very exciting to many companies, because in principle we can make now a paper-based packaging for any type of food without the need for some plastics or for some polymer film or for some other, let's say, difficult to recycle solution here. So we can make, if you have the water vapor and the oxygen, so we can come down to very, very low values. So with this, just to give you some idea, for this type of very good values, you can use basically paper for packaging of coffee, right? And that is not so easy. And again, in this packaging, there's no plastics, not even a thin plastic film. So it's really only paper and almost there, and just a little bit of SRX. So that means that, just to summarize, that means that we have here a toolbox for making green packaging. So it has sort of the almost there and the bio almost there. They have very good adhesion on all kinds of materials, even on natural materials. Very good barrier properties. We can adjust the biodegradability if needed. We can add different requirements and combine them in one single coating. So this can be the food contact is good. So there's no migration of so-called more, no migration of some colorants, etc. So you can even use recycled polymers, and there's no migration of monomers out of that. So again, there are a lot of opportunities, a lot of barrier properties and other properties. And so basically, our coating is very compatible with other coatings and materials. You can overprint it. And of course, as I said, the synthesis is easily scalable and it is suitable for standard industrial processes. And so just coming back to the initial problem statement. In order to get rid and to eliminate the composite film packaging, we have now basically a solution tool to generate so-called monomaterial packaging, so that it's very easy to recycle and or to be biodegraded. So it can be a PLA, a paper, other stuff, other polymers as substrate. Then it can be almost there or bio almost there. It depends. So if this one here is just a polymer, so if the polymer is just a recyclable polymer, then the almost there, which is also recyclable, is okay. If this one here is a paper or is a biodegradable polymer like PLA, then the top coat or the coat, the single coat, it's a single coat, is the bio almost there. And the SRX is always optional depending on the specification. So this is basically the new type of packaging which can replace all sorts of existing polymer packaging. Now, just again, just to make it more clear about the potential options we have here. So basically, we avoid packaging waste. So we can, it doesn't matter if it's fossil-based plastics, if it's a cardboard, if it's a bio-based plastic, or if it's something else. Can be even a natural material. We have the solution for bio almost there or almost there to coat it to make a monomaterial packaging. So it can be monomaterial polymer packaging, paper-based monomaterial packaging, or bio-based monomaterial packaging, and it can be recyclable and or compostable. So in some cases, both is in the same. That doesn't matter. So this is just to show you the opportunity which we have here, and I even want to go one step to show you the future or some ongoing research we have. So here again, we have something which is recyclable. So it's a mixture of inorganic and organic material in one molecule. Composting, but also recyclable. If we add some bio-based molecules to it, and the next step is even for pharmaceutical material or products, for simple fruits and vegetables. Okay, this is more European one, but of course in Brazil there are much more different ones. But again, a direct coating which is edible, right? So that's very important. And here is just to give you some idea already. So here's a potential opportunity that we could use natural products or byproducts from Brazil to make such type of coatings or such type of packaging. I think this could be a very interesting opportunity. And we have already some initial contacts with companies from Brazil on this. So again, this could be something which is interesting. And if you have such packagings, then it would be also very easy to export to Europe or to US, for example. Now here's my almost final slide, just to give you some even more, let's say, high-tech outlook. But our story is always we try to make high-tech, but make it cheap and easy to produce. So in this case, it's also like it is something which can be used in packaging in the future. We have developed also something like a toolbox we call supraparticles. And they are like a bridge between material and digital world. So basically, we can generate these particles. So actually, here is a real picture. So it looks a bit like this inside here, and so we can have an unlimited choice of fluorescent and magnetic codes, for example. So it can be used as a marker to mark even raw materials directly from the mine if needed, all the way through the processing, and even after the let's say use. So it can be if you recycle the material, then still you can trace the material. So you can even if it's directly from industrial waste disposal. So again, that is something very interesting. That you can now, you don't have just an RFID chip or something like that, or some other stuff, which you put on some product or on something, but it's actually inside. But of course, you can also spray it on something. So there are different options. So it's a very interesting. And then behind that, you have databases and things like that. So again, it's a bridge between the material and the digital world. So we even call it a material blockchain. So there are different options like hidden features, like a secret ink, so nobody knows that it's marked, for example. It's also very interesting. So there are different detection methods. And on top of that, there's even one further option. So I'm just opening just another gate here. So, but it's still the same particle, right? That we can add different sensing functions. So, so basically, and this could be interesting, especially for packaging, but also for others. So basically, if there was a gas exposure to a specific gas, for example, because the food is rotten, for example, then some gases evolve, then this type of particle or the packaging, which includes the particle, is changing. So you can see the color is changing, for example, right? And other things. Or if you transport something, right? So you something needs to be cooled all the time, right? Then if the temperature limit has been broken, if somewhere in between, all around the world, doesn't matter, somewhere in between the temperature was too high, then we can basically generate markers which then show that it was too high, and in some cases it can be even showing how long it was too high, right? So again, just different options. Here's some small picture, but let's say you can understand that it's a powder based on this, and it is depending on the temperature, it is changing the color, and we have also already put out some scientific papers on that, so that's so you can read about that. Also the impact. So if for example you ship something which is valuable, and then there was like an impact right somewhere, then again it is changing the color if needed, right? So different options. So it's not it's not let's say finalized here. Okay, last but not least, just to give you some, so we are proud, let's say, to also to present this, that we have been winning different awards already. So there are also some international awards we've been recently winning. They're not even shown here. So again, it is something which is well recognized. And that is basically my talk. Thanks for listening. I hope you could understand most of it, and I'm looking forward to your questions, and especially to the next discussions in the next few weeks and months, and maybe we can help you, and maybe there could be some nice German-Brazilian collaboration.
Let's hope for that, Victor. Thank you very much. Thank you very much for the presentation. It's a nice presentation. I have made a lot of annotations here, so I can ask you as well, because there are, especially at the end of the presentation, are really interesting topics that I have some doubts that maybe we can bring some new project ideas. Victor, I do have a question from a friend, a great friend in Berlin. It's from Fraunhofer IPK, the Luis Schweitzer. He asks, I'll put the question here. Dear Dr. Trapp, is the production cost of almost feasible for a large-scale industrial application?
Can you repeat the last key part of the sentence?
You can get back to the platform. You can stop sharing. Yes. Yeah, great.
That's what I will do, and then I okay, that's easy. Okay. Oh yeah. It's that's no problem at all. We are actually what I can say is that we have different deals with different chemical companies, and for example, with one chemical company, which is a big international blue chip company, they can produce many hundreds of tons per year and ship it around the world. And the cost of this coating is less than 5 cents per square meter of a typical packaging, for example, right? So like this. So it's a very compatible with the need of food packaging.
Yeah, this is great. It's great, Luis. Did Dr. Trapp answered your question? If you have more, please put there, and we can take this your doubts here live. So, Victor, I do have some questions for you. Actually, it's really interesting. Like I said, the first would be: do you have or did you have any projects in Brazil?
We do have different ongoing negotiations and discussions. So we did have already with one or two companies some very specific, let's say, project ideas. And what I can say is that we have clients literally all around the world. So I think and in Brazil, I think there are a lot of good companies. There's a lot of potential to collaborate. Yeah.
Great. I saw. I just want to mention about the how long have you been working with this technology? Like you mentioned, 30 years, and after 30 years, you won the prize of sustainable awards and so on. And just to mention that the people that are watching us, that this innovation, they don't come from the night from the day, right?
Yeah.
What can you mention about it? Because I know that's from a researcher from you that's already she's retired.
Yeah.
But how, and yourself, how long have you been working with this?
Basically, the story is we can make it very short. Actually, we have been dealing with this type of barrier coating in different applications for a long time already. But for the food packaging, until recently, the food packaging industry was just focused on very low costs, and they didn't care about recycling, right? So as I explained at the beginning, so now because of some changing legal framework and also environmental concerns, suddenly, let's say it started like 5 years ago, I can say roughly, right? Suddenly, a lot of companies are, for different reasons, are asking us, "Oh, can you help us?" And so I think we are also in a kind of lucky position that we have the right type of technical solution to many of the problems they have.
This is nice. This is nice. And then it just showed up suddenly, right? Yeah, this is nice to hear because we do have a real problem regarding recycling, and thank God you have developed before the research in this direction. Then we can right now put into the market together with the companies, right? And also help to save the worlds, to improve the conditions of the world.
That's nice. What we are here for. Yeah.
Yeah. Victor, you mentioned that this is one. This one was also a really interesting sentence that you have showed us. It's the bio armor, right? And you mentioned that you using bio wastes, you can produce this film, right? This protection film. And regarding the bio waste, are there from any kind of wastes, or it doesn't matter, or do matter? You need to have these conditions.
What are the conditions? That's a good question. While to a certain extent, I can say it doesn't matter, right? So we can, in principle, we can use any type of bio waste. However, then it's not just using some green stuff and putting it on top of the polymer, but it's of course there's some chemistry involved. So basically, it depends how much of the molecules that we are looking for is inside of the bio waste, let's say, right? But I can say that in the meantime, we are already working on some new generation, like the edible coating, for example, right? And there we can probably use even more bio-waste for this type of coating than for the almost there coating, for example, right? So again, it's something which can be then discussed in more detail, but in principle, we are more looking for the, let's say, for the molecules inside, rather than for any specific bio waste. So then it really depends on how good is the quality of the molecules inside for our type of coating. That's the answer. That's a question, but we have to answer that then very specifically each time.
Okay. Yeah, I ask it that because we in Brazil we are most of our income comes from the agriculture, and of course we have some waste. Yeah, we have also a huge population, more than almost 210 million people, and of course we have a lot of waste, and it's inside of the bio waste.
Yeah. That's why I fully agree, and I think that's a very big potential we see also in collaboration with Brazil, that there is a lot of the quantity, let's say the quantity of the biomass, right, is much bigger, of the available biomass much bigger than what we have, and we are quite certain that if we talk to the right partners in Brazil, that we find we find some nice business case where we can use the biomass or the biomass waste to make, for example, a packaging from that, right?
Yeah, it's true, and we are here to help you out in Brazil.
Good.
Victor, I also found really interesting the part that you mentioned, the material blockchain. It's like high tech stuff.
Yeah.
And my question is, how far are you, or have you already developed? Or it's just an idea with this intelligent packaging, I would say. How far are you?
Yeah. I mean, for intelligent packaging, we have been doing already different type of developments in the past. So even before these smart particles, let's say, right? So we've been really developing different solutions so that the packaging is kind of indicating something, let's say, right? So it's but with the smart particles, we have now really entered a new arena, basically, right? So it's really something where you can basically say, okay, this gives us the opportunity, and also different companies the opportunity to look at the product, or the product, let's say, circle, right, or the material circle in a very different way. So now you can really you can follow the material and the products all the cycle. If you think in cycles, right, then you can follow all the cycle, which and from the very origin, right, from the very source up to the first and the second and the third cycle, right, which is very exciting. So that's like a key to some lock which is still there. Like the other one is really that you can very much now link the material world with the IT world. So it's basically, so far, just giving you an example, of course, you have some suppliers, and the suppliers telling you, oh, I've been using this material with that property, right? And then, but the digitalization of all this means that you just take the data which your supplier gives you, and you put it into a database, right? However, let's put it this way, how can you tell for sure that the data in your database are the correct data, right?
Yeah.
How can you tell that the data in your database is representing really the material properties or the material batches which have been supplied to you, right? The same is true for your own products then going somewhere, right? Even for international logistics, right? So there are many different options. And in this case, again, we just, let's say, opened up a new football stadium, right? and just started to make the first steps on the turf, let's say, right? So it's a little bit like that. So we are not even sure how far this will get us, but we are sure that this is something which can be used for many different type of industries, for many different type of applications. And the good news is it is simple, right? So you don't need let's say you don't need a very sophisticated technology behind that, right? It is because it's just a powder, right, or different type of powders which you use inside of your manufacturing chain or your logistics chain, right?
Like you mentioned, you can use a spray, right?
Just yeah, for example, yeah.
And you can only configure the ID and so on, and you have the identification, and you can also maybe try to communicate automatically from the spray. I don't know, who knows?
Yeah, the future. We can also link it to some electronics or some small antenna. That's also possible. Yeah, good point. And of course, again, that's possible. I think at this point we just rather try to make clear that it's a very simple technology. In principle, for most applications, you don't even need a chip, an antenna, nothing. It's just all you need, and sometimes you even don't need some electronics. You don't need something to read out or something like that, but you just use your eyes, right? So again, it gives a lot of opportunities, and the specific implementation can be sometimes very simple.
Yeah, I do have a question regarding this topic, because at the end I was while we were explaining, I was thinking to myself, and I tried to see if it's possible to have the tracking, like the tracking of the life of for example, the fruit. Like you said, you can see, but is this possible to have the tracking data, like the temperature in this point of the apple, for example, is going up and down? Because when you see at the end, you only see the color there, but you can't see that it has been through a cycle or temperature.
That's a very good question. In some cases, we can do that already. So it's also like a recording function, let's say, right?
Yes. Perfect.
So it's not, and it can be irreversible, and it can be reversible. So again, in some cases, you just want to be sure that if something happens, then it is indicating it, and the indicator stays red, for example, right? So basically, which can be decisive, right? But for example, you can also generate a particle so that they can be like they have something like a recording function. Yeah. So just let's say if
like a memory.
Like a memory. So it's not the same like a complete electronic memory with electronic sensing, but let's say it's easy to imagine that, let's say, we have 3 different type of colorants in there. The apple or some fruit is then exposed to a higher temperature. Then we can adjust it, that maybe if it's the first time at high temperature for more than 6 hours, let's say, right? That then the first set of colorants is kind of changing, right? And then it's kind of it's like consumed, right? So then the colorant is like let's call it dead, right? So then after let's say another period of 6 hours, then the second colorant is dead, right? So again, it is something by the chemistry, let's say, right, we can play a lot of games, I always say, right?
Okay.
So it's really, but of course we cannot, generate miracles. But if the use case is specific, I think even from today's perspective, we can do a lot already.
Yeah. Do you think it's possible to have like you have a threshold temperature like it will only activate once there is 100 degrees, and then you can record this going down like 90, 80, like the colors, but not like you said, it's reversible in the both directions. Is it possible to do? I just don't know. I'm just asking like a curiosity, because you can
I don't
also
know.
you can okay because you can do like going up like the scale of colors, and also going down once this temperature has been reached, and then you can record the going down temperature, I would say, just to see like it went up and you have the layer dead, and then you have another layer that will record the opposite. I don't know, it was just an idea that came to my mind.
That's a good question. I don't know, but in principle, as you know, more than 50% of all innovation comes from material innovations. So again, there are different options, and we have to discuss. Yeah, but we love the challenge, let's say.
This is another research project, right? Yeah. So, Victor, I would like to thank you very much. And also make the last question for you is like, how can we get in touch if we have a question? I just put your email on the screen, and they say the people that are watching, can they get in touch directly to you if they have any questions?
Definitely.
Okay, great. So thank you again, Victor. This was really nice presentation. Like you saw, I just had a lot of my mind is blowing here with a lot of questions. We can discuss later.
This is the idea behind it, and it's also to all the audience. Basically, we quite often just let's say offer the potential solution or give you some idea about solutions. But then the more specific questions are then, of course, to be discussed directly then, yes.
Great. So I would like to thank you again. Nice, the best greetings, regards, and viele Grüße to Germany. And I hope you have a nice week.
Danke.
And thank you again. And I'll keep in touch with you soon.
Yeah, looking forward. Okay, bye-bye.
Bye-bye. Tchau, pessoal. Vejo vocês no próximo Fraunhofer Quick Lives. Um grande abraço.